Section 3.6 of Unit 3 of Math Theory 201 is on independent and dependent events, or dependent events. So this just boils down to talking about the difference between problems where the first thing that you do, the first event, impacts the outcome of the second event, versus problems where doing something first doesn't affect the second thing at all. Those are independent and dependent events. So the first point here is if one event does not affect the probable outcome of the other event, these events are independent. The example given is just tossing a coin, right? If you flip a coin once, the result does not affect you flipping the coin a second time. So we can also say in a situation where with replacement, where you put something back, we create independent events. Whereas if one event does affect the probable outcome of the other, then these events are dependent, right? One depends on the other. So taking a candy from a jar and not replacing it affects the probability that the next candy is picked, right? So if you don't put it back. So without replacement, we create dependent events. So let's look at an example here. It says determine if the events A and B are independent or dependent. So the first one is event A is drawing a queen from a standard deck of cards, and then you keep that card. And then event B is drawing a king from the remaining cards in the same deck. So we've drawn a card, we hope it's a queen, and we draw another card, we hope it's a king. So you should see that once you draw the first card, the number of cards left in the deck is smaller. So the probability of drawing a card from a deck is different than if it was a full deck, which makes these dependent events. Right, where the probability of drawing a queen is, well, there's 4 queens in a deck, there are 52 cards. This is event A. Then the probability of drawing a king next would be 4 out of 51, because we've taken that one card out. Whereas if we replace the card, drawing a king or drawing a queen, drawing any just number from a deck of cards would have the same probability, right? Because there's 4 of every card in the deck, 1 of each suit. Okay, let's look at B, where it says the experiment is rolling a pair of dice. The first event is rolling an odd number on one die, and the second event is rolling an even number on the other. So, the first roll does not change or weight what the roll of the second dice will be. So these are independent events. Independent events because the result of the first roll does not affect the second roll. Right? They're staying completely independent from one another. So we'll look at more examples of these now and how we can use this information in probability analysis moving forward.